Hi guys, so this is Dr. G, and today we are going to start chapter 8 in your organic chemistry 1 class. And in this chapter, we are going to talk about lots of reactions for alkenes and the synthesis of alkenes. So there will be a lot of reactions in this chapter as well as mechanisms. So I want you to uh, maintain your reaction book as I mentioned in class, so it will be very helpful when summarizing all the reactions and understanding the similarities and differences of these reactions. So in this chapter, as I mentioned earlier, we are going to talk about preparation of alkenes. Okay, so that will be the first video. We will talk about the preparation of alkenes. My first video will be on that, and then we will talk about bunch of different reactions for alkenes. So all these will be discussed in one or two other videos. And if you take a look at alkenes, unlike alkanes, I mean, as I mentioned earlier, they have a functional group. The functional group is, of course, a carbon double bond. This is the functional group for alkenes, and then these carbons are sp2 hybridized, and also these sp2 hybridized carbons are highly reactive as compared to sp3 hybridized carbon. So therefore, alkenes have a wide array of reactions. I think in this chapter we will talk about at least 12 different reactions for alkenes. So these are some of the reactions that you will see. We will talk about preparation of compounds like alcohols using alkenes, and things like epoxides or sometimes alkyl halides or even dihalides or diols or carbonyl compounds. All these reactions are very important. So in this lesson we will talk about many different chemical reactions for alkenes. And before talking about the reactions of alkenes, let's see how to make alkenes. Let's see how to make alkenes. And for this discussion, I'm going to discuss two very important reactions. I'm going to discuss two very important reactions to prepare alkenes. I'm going to discuss two very important reactions to prepare alkenes. And both these reactions that are used to prepare alkenes or for the preparation of alkenes are elimination type reactions. They are basically elimination type reactions. So, which means uh, you are removing uh, two groups from adjacent carbons in order to make a carbon-carbon double bond. So basically, in elimination, we are removing two groups from two adjacent carbons in order to prepare a carbon-carbon double bond. And the first reaction that we are going to talk about is called dehydrohalogenation. The first reaction that we are going to talk about under preparation of alkenes is dehydrohalogenation. So basically for this you are going to need an alkyl halide. The reactant that we look for is an alkyl halide. So what is an alkyl halide? So basically you have an R group attached to a halogen, something like a chlorine, bromine, iodine, or even a fluorine. Okay, so you are going to need an alkyl halide. So this right here is your alkyl halide. Okay, so for these you are going to need an alkyl halide, and then we treat alkyl halides with a strong base. Okay, we treat alkyl halides with a strong base. So the go-to base for these reactions are KOH. Okay, but we will talk about a few other bases in the future when we learn more on organic chemistry. But for now, you might want to remember KOH. Okay, so we will use KOH in the presence of alcohols to generate alkenes from alkyl halides. Why do we need an alcohol, you may ask? Okay, of course, KOH is an ionic compound, which means it is not going to be soluble in organic solutions like alkyl halides. So therefore you need a mediator. That is why we are using alcohol as a solvent. Okay, so the first reaction that we learned is uh, the use of KOH in the presence of alcohol medium to generate an alkene using an alkyl halide. All right, let me quickly give you a sample reaction. Okay, so let's say you have an alkyl halide like this. Okay, here is your alkyl halide. I'm going to use a different color maybe. All right, here is your alkyl halide. Okay, and then if you treat an alkyl halide with something like KOH, which is a very strong base in the presence of alcohol, as you see, H5OH. Okay, what happens is that the halogen, oops, sorry about that. The halogen will take a hydrogen from the neighboring carbon. You have two neighboring carbons, you can use any one of these two, and then basically you are removing this halogen with this hydrogen, so you are going to make a double bond. You're going to make a double bond between this carbon with the halogen and the neighboring carbon. Are we clear? So this is how you do these types of reactions. All right, so the next reaction that we are going to talk about is called a preparation of alkenes using alcohols. Okay, for this reaction, of course, you are going to need an alcohol. You are going to need an alcohol, which is basically an OH group attached to a carbon. So these are alcohols. In here, I have a methyl cyclohexanol. Okay, so you're going to need an alcohol, and you are going to treat alcohols with a strong acid. And of course, the go-to acid in these reactions are actually sulfuric acid. Okay, so if you treat an alcohol with a strong acid, and you are going to get your alkene. So similarly, guys, in here you are removing the OH with a neighboring hydrogen. So this is basically a dehydration reaction, because OH and hydrogen adds up to what? Adds up to a water molecule. So this is a dehydration reaction. And then you're going to need a double bond between the carbon that had the OH and the neighboring carbon. So this is how this reaction happens. So we learned two reactions for the synthesis of alkenes. Once again, the first reaction that we learned is alkyl halide treatment with a strong base, and the second reaction that we learned is alcohols reaction with a strong acid. So here is an alkyl halide, and here is your alcohol. Okay, if you have an alkyl halide, you treat it with a KOH, and you can put some alcohol as the solvent. And for this, for alcohols, you need H2SO4, a strong acid, and then THF as the solvent. And then this particular reaction, the first reaction, will give you an alkene, and the second reaction will also give you an alkene. Okay, you simply remove the chlorine or the OH with a neighboring hydrogen. Okay, so in the first reaction you are removing an HCl. In the second reaction you are removing a water molecule. Are we clear? All right, so that is how you synthesize alkenes. And please remember those two reactions, because those two reactions are going to be extremely important. Why? Because alkenes are very reactive. So if we want to make a diverse compound using an organic compound, most of the times we convert whatever the compound or the starting material that we have into an alkene, because alkenes provide a huge diversity when it comes to reactions. So synthesis of alkenes is extremely important. So remember those two reactions, and you might want to write them down in your reaction book. All right, so let's see if you could do this study check. Let's see if you could do this study check. If you are watching the video, you might want to pause now. Okay, you might want to pause now. All right, so here is the molecule that we have. Let's see if I could take a peek. And you have 4 carbons, so 1, 2, 3, 4, and then 4th carbon has an OH. Okay, and then CH2. This is the compound that you have. This is the alcohol that you have, and then you are treating it with probably a sulfuric acid. Yeah. Okay. So using sulfuric acid, so that is a dehydration type reaction. Okay, you are treating this with sulfuric acid. Okay, conc acid. So you might need a solvent like THF, and then let's figure out the products. There could be multiple products. Why? Because as you can see, here is your alcohol carbon. This is the carbon that contains the OH. So for that carbon, you have three neighboring carbons. So you could take a hydrogen from, theoretically, of course, you can take a hydrogen from any one of these neighboring carbons. Am I correct? All right. So theoretically, you can take any one of these hydrogens and then make a double bond, right? Then make a double bond. So you have many options. So if you use this hydrogen right here, okay, that means you are going to have a double bond between this carbon and this carbon. So your product will be something like this. Now you have a double bond here. Then of course you're also going to have a CH3. Okay. So this is a product, but of course, as you can see, these alkene carbons have 4 different groups attached. So therefore, it could be these or the other isomer. Okay, or this. They're both correct. Okay, there is going to be E and Z. I want you to see if you could categorize these two compounds as either E or Z. Okay, so those are two options. And then let's try to use this hydrogen right here. Okay, here is another option. Okay, you can remove a water molecule like this, and then if you do that, you're going to get this product. Double bond right here. Then of course this, or this can also have E or Z. Okay, so you can expect both E and Z. Okay, so now we talked about 4 different possible products, right? So 4 different possible products. So let's see if we have any other possibilities. Honestly, those 4 products are the more possible or more common products. I would say 99.9% of the times you will see one of those 4 products. But let's say you are using this hydrogen. This is also a neighbor hydrogen for this OH. So if that is the case, then you will get a double bond like this. Okay, so this is also a possible product, but it is highly rare. But this is also a possibility, and there is no ENC for this one. Okay, so that is how you answer this question. This is how you answer this question. Okay, once again, guys. So these are your possible products. These are the possible products, and I already explained the products for you. With this, I mean, take time and pause this video, and then you might want to see if you understand all these answers. But with this sample problem, I'm going to conclude this video, and in the next video, I'm going to talk about the synthesis of the reactions of alkenes. Have a good day, guys.